from the confusion matrix. I'll be looking at a matrix to evaluate the performance of a classification model. So we'll look at majorly precision and recall. There's also F1, but we'll look at that another time. So as I've said, the matrix to evaluate the performance of a classification model. So both are classification matrix with classification models, and we try to predict what class an object belongs to. So we build a simple classification model using any objects, could be fruits, could be books, or pens and pencils. So if we build a classification model classifying pens and pencils, with one side classifying pens and the other side classifying pencils. So P for pen and Q for pencils, perhaps. So if our model says, I'll give a rough example, P, Q, Q, P, P, and so if it classifies our pens and pencils in that way, this side it's supposed to put pens, this side it's supposed to put pencils. So we are trying to evaluate how good is our model doing, because we can see that within the pencil section, the pen section, it has some pencils, and within the pencils we have some pens. So accuracy would be total number of an item over total number of, what do I call them, observations. Yeah, that's how we would get the accuracy. Total got right out of total observations. Ideally, this is how we would get how we would evaluate our model, how well it is doing. But precision and roll call work together in some sort of way that make evaluating our model better or much more effective. So when we build a model, we want to see and evaluate to find out if it's doing a good job. One way of doing that is finding accuracy. Accuracy has some issues, especially with imbalanced classes. Then if I had a model and say we had 990 oranges, or pens like we used, oranges, and 10 apples, we could use percentage. Yeah. If we used accuracy, our accuracy here, if the model decided to classify everything as oranges, our accuracy would be 99%. But we're not putting into consideration the 10 apples that we have that have been classified into oranges. So precision and recall give an acceptance for that. Yeah. So we'll start with precision. If we want to calculate precision for the pens or pencils, perhaps, we focus on the pen side. You completely ignore the pens if you want to find precision for the pencils. Precision, we're going to keep using this model that we have created. Precision is equal to precision for whatever you want to find, total number of pencils out of total number of observations. Observation means every single item in the model. So,
could you remind me, this was called what? What was the name of the matrix?
The matrix.
That?
Oh, no, we finished the confusion matrix. This is a follow-up from the confusion matrix. We're trying to evaluate how a model is doing in classifying different things. Classification model.
No, so this is evaluation of the classification model.
Yes.
Okay.
Ways to evaluate the classification model.
Then there is the precision method and recall method.
Yes, we are covering precision and recall versus accuracy. Everyone knows how to calculate the accuracy. That total got right out of total observation. And I gave an example of a model that was classifying oranges and apples with 990 oranges, 10 apples. This model classified everything as oranges. Accuracy would be 99%, but without consideration of the 10 apples that were classified as oranges. So we're trying to find a better evaluation method. Okay, so if we're finding precision, we ignore this bit and only consider this bit. So you count total number of pencils out of total observations. So that is basically pencils got right. 1, 2, 3, 4, 5. Yeah? 5 out of total number of observations. 3 by 3, 9, 18. We ignore the pens bit.
Okay.
So we're only considering this bit. This is 9. 5 out of 9 times 100%. So that would be your precision. Then with recall, it would be total number of pencils got correct, out of total number of pencils in general. Pencils. So how many pencils did we get right? So our model, how many pencils did it classify as pencils and they were actually pencils? 1, 2, 3, 4, 5. How many pencils are actually there? 1, 2, 3, 4, 5, 6, 7. That is how we get our recall. And as we continue with the model, we realize if you change the model, both the precision and recall change.
Okay.
So we're going to look at that. You find a decision threshold. So this is where our model split. Imagine this was a piece of tape and all the pens and pencils were put here. Do you have a pen? So if all the pens and pencils were put here and I decided to put tape here, that is this line, yeah? And classified these as pens, classified these as pencils. That is what we're doing. So we're going to find a decision threshold, that is changing the piece of tape to a different threshold with what we would think are more accurate values. So create another model. Pens, pencils. This is, now we're working with this model. I could decide to change the decision threshold. Cut it from here perhaps. So P. So if I change the decision threshold and cut from here. So do you remember what precision is equal to?
Precision was total number of got right, total number of the items we are finding precision for got right out of total number
Precision,
of observations.
we ignore this bit. It was total number of pencils out of total number of observations, but within the pencils. So precision here would be 3 out of 3 times 100, and this is 100% precision. Now what happens to the recall? What is the recall? Recall is equal to total number got right or got correct out of total number of pencils, which is how many were got right? 3. How many pencils are there actually? 1, 2, 3, 4, 5, 6, 7, 8. 8 times 100. Precision drops. Yeah? Recall drops. So if you keep changing your decision threshold, these values will vary. And that is why it is a better way to evaluate how our model is doing at classifying items, because you'd have to find a way to match the precision and recall. So that trade-off between precision and recall makes it very powerful when building classification models. With precision, you're saying what you're calling a positive actually is a positive. But with recall, you're making sure you are not missing out on positive observations. Yeah? From the previous discussions, I talked about true positives, false positives, true negatives, false negatives. So you can follow from that. We want to find out if what we are calling positive is actually positive. Yeah, the F-score is a harmonic average between precision and recall, but we'll look more into it next time.